And the first exercise, these sample problems, you can find them in your textbook, okay, from page 82 and 90, I think. So those are the pages that we're going to be working today. What is the mass in grams of 3.5 moles of the element copper Cu? Okay, so as you can see, what is the key word in this problem? What is the key word in this problem? I have two
The
keywords.
mass.
Math.
I
Mass in
have
grams.
mass in grams and I have 3.5 moles. Okay, so I am relating mass, which is in grams, and I'm relating moles. So what am I going to be using? Am I going to be using Avogadro's or molar mass? What should I use?
Avogadro's.
Mass.
Okay, I will tell you like the other day. If you're gonna be using Avogadro's, when in the problem, in the question, you have these keywords: molecules, atoms, formula units, or particles. Every time you see those words, remember you're gonna be using Avogadro's, and this is the conversion factor for it. But anytime you see words like grams or mass, you're going to be using molar mass. And the molar mass depends on the element that we're talking about. So if we're talking about sodium, we're going to be using the molar mass of sodium, which is nothing more than the atomic mass, but with different units, just like we did right here. Here. I think I did it in the other. Yeah, it should be that way. Just as an example, as I was mentioning before, sodium in this case, you can see that I am using the atomic mass of sodium, but I change the units. From AMU, I change it to grams over mole. So in this exercise, I am mentioning grams and moles. What am I going to be using? Avogadro's or molar mass?
Molar.
Molar mass.
Molar mass. You get rid of Avogadro's and you focus on the molar mass. So for the molar mass, you need to know the element. Okay? I know you're sorry, guys. Trust me, I hate it so much.
Don't worry, miss.
Thank you. So let's focus on the element. The element is copper. And the atomic mass of copper is
63.5.
okay, 63.55 AMU, and we're going to replace AMU by the units grams per mole. And there are two ways to express this. Okay? There are two ways to express this, and you're going to arrange it in the way you prefer. Okay? And you can write this as 63.55 grams over 1 mole of copper each, or you can say that in 1 mole of copper you have 63.55 grams of copper. So those are the two possible ways to arrange the molar mass, like A or like B. Okay, those are the two possible ways. So we always begin with the given. We say the given is 3.5 moles of copper. Okay, so the conversion factor, the molar mass that we're going to be using, is going to be like A or like B if I want to get rid of the moles.
Like A.
A. So I say 1 mole of Cu has 63.55 grams of Cu. Get rid of it. And how much is this?
Two 222.43.
Exactly. And with this, we say that is over. We answered that question. Now let's see another example. A chemist produced 11.9 grams of aluminum Al. How many moles of aluminum were produced? This is a review, okay? We had the weekend. So, I'm giving you grams of aluminum and I'm asking you about moles of aluminum. So, what am I going to be using? Avogadros or molar mass?
Molar mass.
Molar mass.
Again, molar mass, because the keyword here are the grams right there. So if you see grams or mass, it means that we need to be using molar mass. So we begin with the given. Well, we get the molar mass first, okay? So the element is aluminum. What is the molar mass or the atomic mass of aluminum?
26.981.
26.981 AMU. So the first step is to get rid of the AMU by grams per mole. So the molar mass is going to be 26.981 grams over mole. And the two ways to express it, like A or like B. So you say that there are 26.981 grams of aluminum over 1 mole of aluminum. Or you can say that there is 1 mole of aluminum, and inside of it you have the 26.981 grams of the same unit aluminum. So those are the two possible ratios that you can use as conversion factors. So
Always at the denominator is gonna be 1 mole, and
yes, always
symbol.
1 mole. The molar
Okay.
mass is
It
always
will depend.
1 mole. Yes.
No, that it will depend. Only that we should consider that always gonna be 1 mole.
Yes, exactly, because all the atomic masses in the periodic table are for 1 mole. So if you have 2 moles, it's going to have the double amount of grams. But that's why we do the conversion factor, you know? That's why we do the conversion process. But yes, the factor here is always going to be 1. So we begin with the given. 11.9
11.9 grams of aluminum.
So what conversion factor I should use? A or B?
B.
B,
B.
because we're looking for moles.
Exactly, we're looking for moles. So the moles are going to be in the top, and the grams of aluminum are going to be below. You can cancel the grams of aluminum with grams of aluminum. And how much is this?
0.44.
0.44.
0.44 moles of aluminum. Where do I get the moles of aluminum? From here. The only thing that I didn't eliminate. And with this, you finish the As I told you, it's like a conversion process. And
Miss, could you
anything?
please show the first exercise a few seconds? Thank you.
Okay. So let's take a look to this one. I think this one I already did. I remember this example. No, sorry about it. I'm pretty sure that I did it. And I think the one of copper too, but I'm not very sure about it. But I want to assign this homework, and so I need to be sure that I have all these type of problems done by me. Okay. So this one says, what is the mass in grams of 1.8 times 10 to the 8th power atoms of copper Cu? This one I haven't teach. I haven't taught it, I think that's the way to say it. And this one is interesting because I am giving you grams. That's one of the keywords, and I'm giving you
Atoms.
atoms. Okay, so if I give you grams, what conversion factor do you have to use? Molar mass or Avogadro's?
For
Molar.
grams is molar mass.
Molar mass. And when you see the word atoms,
Atoms, Avogadro's.
Avogadro's.
So as you can see, when we have this kind of problems, we're going to be using both molar mass and Avogadro's. It's a two-step conversion. It's like the most difficult conversion, but still very easy to make. So, because we are going to be using molar mass, we need to take a look to the atomic mass of copper. Okay, what do we know about copper? It has the atomic mass of 63.55 AMU. Okay, so as you know, we can write this in two ways, like A or like B. So you can say that there are 63.55 grams of copper in 1 mole of copper, or you can say the otherwise 1 mole of copper that you can find 63.55 grams of copper. That's all you can write about the molar mass. Now for Avogadro's, you know we need to use Avogadro's as a conversion factor. So because we're using atoms, the conversion factor will have atoms and the Avogadro's number. Okay, so this conversion factor could either be 6.022 times 10 to the 23rd power atoms of copper in this case, over 1 mole of copper. Or you can say, this is going to be, I'm going to call this C and I'm going to call this D. Okay? Or you can write it in the other way, which is that in 1 mole of copper, you're going to have Avogadro's number, atoms of copper. Those are the 4 possible conversion factors that we can use for this kind of problem. And as I always tell you, we always begin with the given. So let's take a look. The conversion process will be 1.20 times 10 to the 8th power atoms of copper. Now, if I want to get rid of atoms, what conversion factor should I use? A, B, C, or D?
D.
I need to use D. So I write 6.022 times 10 to the 23rd power atoms of copper that you can find inside 1 mole of copper. Eliminate the atoms with atoms of copper there. And now, what conversion factor should I use to get rid of the moles? A,
A.
B, C, or D?
A.
So I say in 1 mole of copper, I have 63.55 grams of copper. With this, I can get rid of the moles of copper with moles of copper. And we perform this in the calculator. Uh, how much do you get?
1.27
1.27
times 10
times 10 negative 14.
negative 14.
And the units? Grams
Grams of
of
copper.
copper. So you see, this one is a little bit more complex because you need to do a 2-steps conversion. But still, we're doing the same that we did before. We are using Avogadro's number or we are using molar mass. It is like it's combined, okay? So right now, I'm gonna give you mass and I will ask you how many atoms, okay? And I ask you to find the amount of atoms, okay? For us to practice again this one. So I'm gonna use copper because, well, I'm gonna use aluminum because that's the other molar mass that we have here. Because of the time, okay? Remember that you have to vote today. So I'm gonna ask you how many atoms of aluminum are in 200 grams of aluminum. How many atoms of aluminum are in 200 grams of aluminum? Again, here you take a look to the keywords. I'm asking about atoms and I'm giving you grams. So if you see atoms, this means Avogadros. If you see grams, that means molar mass. And because we are using 2 conversion factor, it's a 2-step conversion. So because we're talking about aluminum, we're gonna write all the possible conversion factors. For Avogadros, we have that in 1 mole of aluminum, we have 6.022 times 10 to the 23rd power atoms of aluminum. Or we can say that there's 6.022 times 10 to the 23rd power atoms of aluminum are inside 1 mole of aluminum. Now this is my A and B. And now the molar mass as a conversion factor. Can you tell me molar mass for aluminum?
26.981
26.981
Grams of aluminum in 1 mole of aluminum. Or you can write it in the other way. In 1 mole of aluminum, you have 26.981 grams of aluminum. Those are the 4 conversion factors that we're going to be using. So we start a conversion by the given 200 grams of aluminum. What conversion factor should I use to get rid of the grams?
C.
B. No, A.
A, B, C, or D?
D.
D,
You're getting
because
the
in D,
grams.
I have grams below, okay? So yes, it is D, 26.981 grams of aluminum inside 1 mole of aluminum. Get rid of it, and you continue. What conversion factor should I use to get rid of the moles of aluminum to
C.
obtain
B.
B.
B? So you say 1 mole of aluminum, 6.022 times 10 to the 23rd power atoms of aluminum. How much is this?
4.46 times 10 to the 24 power atoms of
Atoms of
aluminum.
aluminum.
4.46
40.
46
times 10 to the 24.
The 24th power atoms of aluminum.
Two-step conversions. Remember, you write the units that you didn't eliminate. Atoms of aluminum. Okay, guys, I'm gonna leave it here because we have the elections